Today's lesson is on literal equations. Literal equations is when we're going to take away some of those numbers and add in variables. So this is when you're going to see, we're going to be using this for when we're graphing. You're going to use this in science class. So this is something that may be a little bit more challenging, but we're going to need to know it. So first, number one, this is a problem that we've seen already. So first step you would do is subtract 4, right? And then you have 2x is equal to 6. Then you would divide by 2, because remember it says solve for x, and you get x equals 3. Okay, that's something that we've done this whole time. But if you look at a problem like number 2, it's the exact same problem, but our 4 turned into an m, and our 10 turned into a j. So the steps that we go about with solving when we only have maybe one number and multiple variables, or maybe just variables at all, is the same as we would go about to solving problem number 1. So in problem number 1, the first thing you did is you subtracted 4 because we're solving for x, which means we have to get that variable alone. So everything has to be moved to the other side. So we're solving for x in this problem here, so we have to subtract that m. So we have 2x is equal to, well, we don't know what j minus m is. We don't know what their values are, so we can't say it's f. I don't know. So we would have to, when we say it out loud, j minus m, that's how you would write it. The way you say it is the way you write it. So j minus m. The second step was to divide by 2. Well, since we have 2 next to x, we're still going to do that step. What you do to one side, you have to do to everything on the other side. So x is now equal to j minus m divided by 2. The exact same problem, 2 completely different answers, because we don't know what j and m are, so we cannot simplify them. So we're going to start with some easy problems, and then we're going to go on to a little bit more difficult. So here, it's always going to tell you what to solve for. I like to highlight or circle or something to kind of say that this is the variable that I'm trying to get alone. And then I ask myself, what's happening to that variable? So here I have 2 times x. And the only way to get rid of that times is to divide. And to get rid of the x, I have to take what's not highlighted. I have to divide by 2. So x is equal to y divided by 2. In problem number 4, again, we're solving for x. This is a little bit different because now it's x is divided by 2. And we have to take what's the opposite of division. It's multiplication, and whatever is not highlighted is what I'm going to multiply by. So our 2's will cancel on the left, leaving us x, and then 2j would be our answer. If you gave me j times 2, I would accept it, but I'd probably write you a note saying, hey, please remember that the number comes first before the variable. So 2j would be your answer. 5 is a little bit different. Now we're adding, and it says solve for a. So here is the variable that I'm going to solve for to get alone. Since I'm adding a to b, I now have to subtract b from both sides. So I get a is equal to c minus b. How you say it is how you write it. In problem number 6, a plus bc equals d. In this problem, we're trying to get a alone. Think of bc as like 9x, right? In order to move that to the other side, you would just add or subtract it. You do not have to multiply, you do not have to divide. You just add or subtract to move that all the way over. So we can move this whole term, bc, to the other side just by adding or subtracting. So you have a is equal to d minus bc. In problem number 6, the variable we were trying to get alone was not included in that multiplication statement, b times c. So we were able to move it all by itself. But in a problem like number 7, a variable we're trying to get alone is attached to that multiplication problem. So we have to think about this as if we were solving a multi-step problem. Look to see if you can add or subtract first. So in this case, we can subtract our b. We need to get that ax alone. Okay, again, we're solving for a, so I'm going to re-highlight it just because we're not done with it yet. And on the right-hand side, I'm going to read it, c minus b, and that's how I write it. To get a alone, we're multiplying it by x. You have to divide by the letter that's not highlighted. So we're going to divide everything by x. So we have a is equal to c minus b over x. In problem number 8, look, we have numbers again. Yay! We need to get x alone. So first thing you would do, you're like, oh, I know this. I'm going to subtract 2. Good job. So we have 2x is equal to, well, can I say 2m? No, because this one does not have a variable. So it's just 4m minus 2. The next step to get x alone is dividing by 2. And what you do to one side, you have to do to everything. At this point, since we have numbers, we have to look to see if we can simplify. So x is alone. 4m divided by 2 is 2m. Negative 2 divided by 2 is negative 1. And that would be your answer. So if you have numbers, please make sure to look to simplify. Number 9 is a problem or a formula that you're going to use a lot in science classes. It's distance equals rate times time, okay? If your science teacher, or me, your math teacher, gives you your distance and your time, and I want to know the rate. I want to know the rate, meaning we're solving for r. What would you have to do? Well, since it's rate times time, we would have to divide by time. So this means you would find your rate by taking the distance you traveled and dividing it by the time. So like I said, you're going to use this in science too, not just math. Y equals mx plus b is the slope-intercept form. We're going to get into this a lot, really deep later. And we're going to have some fun with it with graphing and being able to write equations. This is one of the forms we'll write it in. But for now, we're just going to solve for x. So since x is attached to one of the variables, we have to move what's not attached to it first. So we would subtract b. mx is what's left on the right-hand side, and you would read this as y minus b, therefore that would be your answer on the left-hand side. But our variable's not alone, so we have to do something to it. It's m times x, so we would have to divide. So our answer would be y minus b over m. In problem number 11, we need to solve for w. Okay? In order to do that, we have length times width times height. We have to divide by something to get alone. We would say LH. We can move more than one variable at one time. LH. So our width is going to equal the volume divided by the length times the height. 12 is super easy. Come on, we can just subtract 10 and get k equals 2. For 13, just like 11, we had all multiplication, so we were able to move LH. Here we have all addition, and we're just trying to get j alone. So we can subtract 2k. A lot of people want to divide, but that would only be if we were going to solve for k. Okay? So we have to subtract 2k and subtract m from both sides. Again, you can do more than one at one time, which leaves your j alone equals 12 minus 2k minus m. 14's in your homework, so I want you to try that one on there. And so is this one. So those are going to be in your homework. I want to see if you can get those. One more thing we're going to talk about, and it's rewriting equations in function form. Function form is a vocabulary term that you're going to have to know, that basically whenever you see it, you know that you have to solve for y. You may also write an equation where y is in terms to x. And you'll see that on your homework tonight, which basically means solve for y. So what we're going to be doing in the next 4 problems is we're going to get y alone. That's our goal, is to get y alone. And the reason behind this is because we're going to use this so much for graphing. And if you think back to when we were putting things into our calculator, it was y1 equals, y2 equals. We have to have that in order to graph. So it's clear that it has to be y equals, so x and y are not allowed to be on the same side. So your first step to solving is get rid of that x. So since we have a positive 2x, we're going to subtract it, minus 2x. So we have y equals 9 minus 2x. Is there anything next to y? If you say no, that's your answer. Looking at 17, again, first step is to get rid of the x. We have a negative 2x, so let's add 2x to both sides. You get 5y is equal to 15 plus 2x. You still have something being multiplied to y. So because of this, we have to add one more step, and it's to divide by that 5. Remember, what you do to one side, you have to do to everything else. So we have y is equal to, we have to always look to simplify, 15 divided by 5 is 3, plus 2/5 does not simplify, so that's what stays. In problem number 18, again, first step, move your x. So we have negative 3x, so we would have to add 3x. So you have 8y is equal to 16 plus 3x. To get y alone, you now have to divide, and you would get y is equal to 2 plus 3/8 x. I'm going to do number 19 and 20. You can try on your own, otherwise start your homework. But to get y alone, we have a positive 3x, so we would subtract 3x. You have minus 4y is equal to 18 minus 3x. When you divide by a negative 4, you have to take that negative with it. We have y is equal to, well, 4 doesn't go into 18 evenly, but we can simplify to 9 over negative 2. Two negatives, negative 3 over negative 4 makes a positive 3/4 x. This is the back page of your homework tonight. So I know it doesn't say function form, it says put y in terms of x. So please make sure you are solving for y on all of those. The front page is more literal equations. We will be spending another day on this, so if you are so confused, please do not worry. We will spend one more day on it. Otherwise, I hope this helps, and have a great day.